Hello, friends. We are back of episode 227 of the R Weekly Highlights podcast. This is the weekly podcast where we talk about the awesome highlights and additional resources that are shared every single week at rweekly.org. My name is Eric Nance, and I'm delighted that you joined us from wherever you are around the world. And no, I'm not at my lonesome this time around, thank goodness, because boy, oh boy, it does get lonely doing it solo. My awesome co-host is back, Mike Thomas. Mike, yeah, I know you had to be off last week. Hope things are better for you. How are you doing?
Much better. And thank you for taking the helm solo last week. We're also in the middle of a little bit of a tech transition for the podcast as well. So you took the reins on that, and so far so good, I think.
Yeah, the proof will be when we get this out in the RSS feed. But thanks. I'll just say this right off the bat. One of our longtime listeners, John Harmon, did correctly see a little audio shenanigans last time around. I will just reiterate for the listeners out there. Mike is right. We are now using a new platform to connect to each other virtually, and is actually the same platform as the Shiny Dev series. So I'm going back to my roots on that one. But also, I switched audio equipment back to what I thought worked well before instead of a new thing that was causing me all sorts of chaos. So we'll find out after this. Either way, I call this another beta test episode, but you're here for the content, not for me rapping about audio engineering. We have an awesome issue to talk about this week, and our curator for this issue is the esteemed Colin Fay, author of all things Golem and other many Shiny related utilities, and also a longtime R-Wiki curator. And as always, he had tremendous help from our fellow R-Wiki curators and contributors like all of you around the world with your pull requests and other wonderful suggestions. And certainly we do try to talk about topics that, give us, a boost in our morale with data science at the forefront of it. Data science is at the forefront of this, but it is about a topic that unfortunately in the real world does happen from time to time. And we are in the midst of one of these situations currently. But we can use a little data science to kind of see what the future might hold, along with learning from the past on this. So we are going to talk about a great blog post that has been authored by Peter Ellis on the Free Range Statistics blog. And this post is about analyzing durations of wars in the world, both in the past and looking at what's happening currently. So I don't think you need me to tell you that we are in the midst of a conflict with regards to nations such as the United States, with Iran, that there has been, lots of news on this. We're not a political podcast, and we're always going to just wish everybody well and hope that this conflict does get solved sooner than later, with everybody relatively healthy, all things considered. Nonetheless, Peter's interest in this certain situation would be we are at approximately at the time of his blog post writing about 74 days so far into the conflict. From past experience with other war durations and looking at some statistical prediction methodology, what can we say about where we're at in this current cycle and when we might be able to predict when the war could actually end? So he starts off a blog post looking at a distribution of the past data, which, by the way, this data does come from the Correlates of War service or data set out there. There's a link to that in the blog post. I have not looked at it myself, but it looks pretty comprehensive. And one thing to note is that this data set talks about not so much intra wars, such as, say, civil wars inside a country, but between, nation states, between each other, which is what we typically see out there. So when you look at this plot of the empirical distribution along with a simulated version of that, we do see a fairly normal looking distribution. And there are definitely some tails in that. But the median length of a war, according to this data and the numbers he crunched here, is about 139 days. But the average is 408. Wow, goodness, that's quite a discrepancy right there. And of course, that doesn't give you a whole lot of optimism, but it was interesting to see what are some of the outliers in this data set. Apparently, there was a war that only lasted 4 days that was so-called football war between Honduras and El Salvador. And then the other extreme is over 3,700 days, which has been called the Vietnam War Phase 2, involving USA and obviously Vietnam and a couple other countries. So, like anything in the real world, we got a lot of skewness at play here. But he's got the code right here that gets to those visuals and the ggplot2 with some data munging with the tidyverse and fitting, looking at the empirical distribution as well as fitting a basic, prediction curve along with that. So speaking of prediction, now what he really wanted to answer is me looking at the conditional expected duration of a war, given that it's now lasted 74 days, as we are at currently of the Iran conflict, and where that might lead us into when that might be fully resolved. So the next visual in this post looks at the empirical cumulative distribution, CDF for the stats folks out there. And that is fitted on this plot. And then also a low-as smoother that is over plotted on top of it. And you can see they have pretty close agreement since they are fitting with each other. But then he does have annotations on the plot looking at where we are with the current timing of the Iran war, which again is at 74 days on the x-axis, and the y-axis being the cumulative frequency of the war. I need to zoom in a bit so I can see that better on my screen here. And then fitting with that is the median expected conditional with the war happening at least 74 days. And on the log scale on the x-axis, it is looking like it is going to be about 261 days, according to this, for the war to conclude. Obviously, we hope that it is much sooner, but it is also important to note that this is a prediction after all. There are other wars that have resolved around that, near that 70-ish day mark in the data set. So he's got the code to produce that in the blog post as well. Very nice use of ggplot, use of the low-s function to do that low-s curve. It's a very good looking plot that gets you to the point relatively quickly. But also you can extend that conditional, observation methodology with not just the median, which is also known as the 50th percentile, but you can look at different percentiles along with that to do different prediction intervals, such as 80%, 90%, and whatnot. So then from this table he shows in the post here, it would be only 10% of wars will typically have a total duration of about 95 days or less. So again, not the best news, but in essence, it is being shown empirically what we could expect. And then the post concludes with an interesting look at some other factors and other relationships that might influence this duration as well. And this next plot, really interesting here, we have a faceted plot of sorts with the duration on the x-axis and then the number of battle deaths. Sorry for that. Yep, number of battle deaths on the y-axis. Obviously, you want less. But this is interesting to look at the nearly 2-century duration of this data of these interstate wars, and that the pattern does exist. Longer the war goes, likely the higher the deaths. I know that's not exactly a radical viewpoint here, but you do see it empirically, and that's what is interesting here. There is another plot at the very end here, looking at additional information with annotated scatter plot with the shape of the points being the number of battle deaths as the duration of the point, or the size of the points, and then the x-axis being the duration of the war itself. Again, you can kind of see a similar shape of this in the relationship. All the code is here. It's great to have access to this data set to do some additional investigation into it. And certainly while this is giving us somewhat of a bleaker picture in terms of how long this might last, as always, it's always good, at least in my side, my perspective, to use some more empirical looks at this, to not just conjecture it, but to put some, statistical evidence around it. So very great, content here from Peter, and definitely learned a lot, and may play with this data set more in the future.
I really enjoy Peter's blog, Free Range Statistics, and he's a great follow on Blue Sky as well. That football war that you mentioned, the 4-day outlier, that was around, what we call in America soccer and the rest of the world calls football, and a World Cup qualifying match in 1970. So a little bit of trivia as we head into the 2026 World Cup here in just a couple weeks. And obviously, hopefully, the tensions for this year's World Cup stay on the field,
right,
not off of it.
Right.
As a side note, I love survival analysis. I see so many applications for it in the wild. And to be honest, in my day-to-day work, when it comes to predictive modeling, more often than not, I'm employing a survival model because I have longitudinal data, and I want to make use of that data over time, as opposed to more traditional machine learning, where if you have longitudinal data, you have to decide how to summarize it or aggregate it or filter it to get sort of one observation per entity that you're trying to model for. Survival analysis really helps remediate that issue and that assumption that we run up against in traditional machine learning. And Peter did a great job walking through this, exploring how to predict that total length of a conflict that's already underway, employing ECDF modeling combined with that lowest smoother, as you mentioned, to model values not exactly matched in the historical data. And I think some of the takeaways in here were definitely fascinating, such that if a war has reached 74 days, like kind of our current USA Israel-Iran conflict, historical data suggests a median total duration of 261 days. So take that as you will. And again, I really think that what Peter's detailed in here is a great masterclass in applied statistical inference on real world data. Doesn't really get any more real world than this. And it's phenomenal that he provides us with the full code for importing that data, generating those plots, and showing how we move from the raw data to that 80% prediction interval. And I guess maybe as a side note, obviously this is kind of a weird data set, or difficult to talk about diplomatically, if you will. I'm sure we all have our personal feelings, but we don't want to espouse those on this podcast necessarily and try to stick to the data side. But I would be interested to see if over time the trend of that battle deaths metric for wars of the same length decreases, maybe as we have more sort of targeted and less human involved conflicts in the future. But great blog post. Definitely continue to check out Peter's blog, Free Range Statistics, in the future.
Yeah, he's been a frequent contributor to past highlight sections. And yeah, I definitely learned a lot from both the data processing side, the visualization side. And there are a lot of interesting additional hypotheses that, like you, Mike, I have some thoughts in my head of what I might want to turn loose on if I was going to analyze this more full time. So as always, I have a link to that in the show notes. And again, great work by Peter on these additional visuals. And up next in our highlights, we're going to continue our use of statistics in data science with this next post here about a fundamental concept that I know I learned long ago in my graduate school training and undergrad in our statistics courses, about a very influential statistic from many years running. But there are some potential caveats you might want to keep in mind in terms of what it might tell you about that model fit you're trying to perform. And we are going to be talking about an excellent post, and Mike and I rehearsed this. We'll see if I get this right. Holger von Dietrich. Well, you know how to find me if I didn't get that right. In any event, he has authored this great post that is titled Learning data science, why a high R squared can be misleading. Oh, yes, I think I know where this might be going, but as always, I learn something new every time I read these. So you might see outputs, whether in your day job or you see reports of from manuscripts or other, computing, statistical computing outputs from R or whatnot. And in a typical model, you will see a high level set of statistics about the overall goodness or the quality of that fit. One of those is called R with squared. And no, this isn't just my clever joke to make R really, really powerful, although I would love to do that. This is the R squared that is known as the coefficient of determination. It is on a scale, you could think of like a percentage from 0 to 1. And ideally, you would want something pretty close to 1. That's typically what you hear. And yes, for the most part, that's true. But you do want to exercise a bit of caution on what that number means in relation to the model you are fitting. So let's dive into the middle of this, or actual meaning of this, as we say. The coefficient of determination is actually a calculation that is, in essence, based on two very important parts dealing with the variability in your model. There is the total variation in your target variable, you might call your response variable, that you're trying to model. Maybe that's a response rate and treatment effect. Maybe that's a revenue or whatnot. Could be all sorts of things. But then you have an important other component of that, which is in a numerator of this fraction at the hood of this, which is the remaining unexplained error after you fit the model on the observed data. Because, we'll get to this a bit later, it is extremely rare that you're going to have a model that will fit the data perfectly. So there's going to be some that's left due to chance or other factors because it's real world data after all. So, in essence, the coefficient of determination is measuring the proportion of variation that's actually explained by the model, because we're doing 1 minus this ratio of what's unexplained over the total variation. So the extremes of this mean that if you see an R squared of 0, you basically have a model that doesn't explain jack squat in terms of the variation. But if you have the other extreme where you have 1, you've explained everything perfectly. That should sound too good to be true because it basically is. But we'll get to how you might get there. So he's got some interesting examples here. We're going to start with a very basic mean model. And no, it's not a snarky model. We're talking about the actual mean in terms of a statistic. That you completely ignore, let's say a model is looking at, age and some other factors. And let's say you ignore and you simply predict, the model, I should say, is looking at whether age can accurately predict average income for an individual. But let's say you don't care about age. You're just looking at the average income itself. No one would really do this, but follow my logic here. Then you have a situation, because you don't have any other terms in this model, that formula for the coefficient of determination is going to give you a big fat 0, because you literally cannot explain anything. This is a microcosm of underfitting of sorts. You've got a model that simply doesn't have anything really to do with the data you're serving it, because you're ignoring age here. Now the other extreme, where you can have what's called a polynomial model, where you might have, say, if you have n observations in your data, let's say you had 100, I say patients because I'm life sciences, 100 people with their income recorded, and you have their ages, but you could fit a model that takes this age, but it also does it more than once, such that you can have up to n minus 1 degrees of a polynomial, in essence, a whole bunch of terms, like 99 terms of this age factor here. And that would be, again, you probably can see where I'm going with this, pretty extreme in terms of fitting, such that if you do that kind of model, you will likely get an R square value, or coefficient of determination value, of 1, meaning you got a perfect fit. But again, perfect fit to the data you give it. May not necessarily be perfect to the data that you're trying to predict, because the whole point of modeling is to predict what we don't have yet, and much like what we talked about in the last highlight here. So that, again, you may think, great, one, I can't do any better. You're right, you can't do any better because you were doing it on the observed data. So you want something in between, right? And that's where, typically speaking, when we look at these modeling approaches, you start with a linear model. You might say, age is not this whole huge degree polynomial interaction. But even with that, you might lose some things here, here and there. But you will see in the visual that he puts in here, it's in between the two extremes of the mean model, literally a straight line of the average income on the horizontal side, but then the polynomial, which is a fancy looking kind of Loess-like curve, but it's just going wild, right? And then he references one of the most famous quotes in statistics from George Box. Yes, all models are useful, or all models are wrong. Like I said, practical models can't explain all the variation, but yeah, there are some that are useful. So you want to maximize as much as you can in R squared, but without sacrificing, I should say, your ability to do prediction here. So there are a lot of interesting points to note here. And Mike, why don't you close us out by kind of the summary here? Why just this statistic alone is maybe not quite sufficient in real practice?
I could shout this from the rooftops, and I really appreciate that Holger is doing that in this blog post here and really demonstrating the different situations in which leaning too much in your R squared value can lead you into trouble. And, this kind of goes along with a lot of other easy pitfalls and traps that we see all the time in statistical modeling and machine learning. And I think one big one here is just please evaluate your model's accuracy on a held out test set, right? That helps you avoid so many of these issues. If your model's accurate against your held out data that it's never seen, then go ahead and refit it on all of your data before deploying to production. I don't know if that's a contentious take or not, but I don't necessarily think so, because sort of the model fitting process is really to evaluate sort of which predictors or independent variables that you want to include in that model. But anyways, just like sort of Jenny Bryan has some infamous rules for good project-oriented programming in R, such as not running set WD or rm list equals ls at the beginning of your scripts. I think she actually more recently posted on Blue Sky that she has a new one. If your agent prefaces every tool call with CD to the current workspace, she's going to come set your data center on fire. I feel like maybe Holger and Max Kuhn and Julia Silge could have a set of these. I'll come and set your computer on fire idioms for predictive modeling, like leaning too heavily on R squared, evaluating model accuracy against the training data. I mean, that's just sort of a real big no-no. I know there's a lot of random accuracy statistics that have been created over the years and are pretty legacy. I don't know if you've ever heard of like KS, Kolmogorov, Smirnov.
I sure have.
Like that.
Yes.
Yeah, which, in my line of work in credit risk and fraud detection and things like that, tend to get a lot of use, even though they have a lot of ways that they can go wrong. Sort of, they're not necessarily holistically measuring everything that you need to measure to get a good understanding of how accurate your model is. They can be pretty biased. So I think there's kind of a laundry list of those things that you have to navigate during the art form that is predictive modeling. But R squared is certainly at the very top, and I appreciate Holger kind of giving the rundown of the different places where it can go wrong.
Yeah, there is a lot to chew on in this, and a lot of this is also you're going to learn from experience here, especially when you get to those real world settings. my hope, and again, you're talking to, I call an old timer here in terms of last time I was in statistics courses over 20 some years ago. I'm being generous there. The point being is that I hope the students of today's, statistics and data science programs are getting experience of real data sets, because I don't want just the textbook examples to always be the basis for everything. And I think that when you get hands-on experience, you combine that with some of the great work that you shouted out earlier with the tidy models ecosystem, and how concepts like training and test and cross-validation are embedded into the core of what you do in a model fitting pipeline. That is definitely more akin to what is actually happening in practice. So R squared, yes, it does have a place, but it is not the only end all be all in terms of judging how your model actually performs. There is a lot more to chew on, but it is great to have this as a basis for your future prediction adventures. Last but certainly not least in this highlight batch for this week, we have a little celebration of sorts to talk to you all about today, because I am happy to say in this last blog post that we're highlighting here, the esteemed rOpenSci project, which has had, massive influence across the world of R and data science and reproducible research as a whole, has just celebrated 15 years. So this blog post is coming from the official rOpenSci blog and the rOpenSci team, to be exact. And this is how they found this out. So a lot of times, well, maybe not a lot of times, I don't get enough time to do this. We look at maybe past communications, past, blog posts or whatnot. And, they wanted to see, based on the conversation they were having, when did rOpenSci actually begin? So this post shares the story. Going back to July of 2011, and there was an email sent about having a collection of things to help with reproducible analysis, reproducible research. A shared blog, a catchy domain name, and a way that you can get R package authors that are passionate about doing open science. In other words, fully reproducible, auditing the code, auditing results. And somehow out of that, rOpenSci became that catchy name. And then there was, even before that name was established, there were commits that became certain packages that would be part of this, such as text size and tree base. And they, again, from their words here, they planted the seed to a much bigger vision. So that is amazing. It is a long time in the world of open source for an effort such as this to exist. And of course, it needs to be mentioned too. Yes, there have been people that have come and gone from the rOpenSci core, group, but there are certain ones that have been in place since day one, but also the culture that they fostered of not only their core group, but then the onboarding process, which I stand by my opinion here, it is some of the best onboarding quality review process you will see in the entire open source ecosystem. We have patterned many things that my team does based on their software review process. It is open, it is transparent. There are no gotchas. There are no hidden agendas. It's all in the vein, all with the meaning of open science at the core. Absolutely love it. So I always have to shout that out every chance I get. So they're saying, well, what can we do to celebrate this milestone, right? Well, they got a couple events that we'll tell you about. They have a co-working session happening on June 2nd. And then also for a couple weeks after that, they will have virtual celebrations both on June 10th as well as June 17th across multiple time zones. So that will be composed of small group conversations for about 90 minutes. and you may meet some new people, and you can talk about rOpenSci's past or predict the future, probably both. And it's going to be a set of friendly faces together. So if you've been involved in the rOpenSci project or just even want to celebrate with them, it's free to everybody. This isn't, a lockdown group by any means. So definitely check those out. We'll have a link to the post as always. And yes, do I hope that they last another 15 years and more? Absolutely. And anything we can do as a community to give them their kudos and give them our support, I will always be forefront at trying my best at that. I have very, very important friends in the R community, even at my day job, that are very embedded into the rOpenSci process, and I hope they get to continue that as long as rOpenSci continues their efforts as well.
Couldn't agree more, Eric. And if you're not familiar with rOpenSci, we'll put some links in the show notes for sure. But it's a very, I think, unique community and organization that's grown and obviously been in place for 15 years is incredible. I was looking at the first release of that tax size package that they spoke about having early commits on. It's showing a first release of December 2012, almost 14 years ago, which is pretty incredible longevity for a package that's still very much actively maintained and worked on. And as you mentioned, right, they're hosting co-working sessions June 2nd and those virtual celebrations on the 10th and the 17th. And I would say whether you've reviewed code, contributed to a package or just used their tools in your research, and I can pretty much guarantee you if you're an R developer, you've used at least one of their tools. This is a great week to celebrate the infrastructure that makes our work possible in the rOpenSci team. So I would say put your party hat on and join them virtually, at least on the 10th or the 17th.
Yeah, I'm hoping I can make at least a little bit of an appearance there. Like I said, I know some very important people in my data science life and elsewhere, such as Will Landau, author of Targets. He is very much a part of the rOpenSci effort with his ecosystem of packages. So yeah, there's so many that we featured. In fact, our fellow curator Al Salmon has been heavily involved with rOpenSci as well. Yeah, so lots of great people out there. I've always said open code is great. That's just one part of the story. I value the people and the organizations behind it, and I am very happy to see this celebrated. And like I said, here's to many, many more.
And I do this every so often, and so I might sound like a broken record, but this is something that we do at Catchbrook every year. We donate to NumFocus, which is the organization behind. It's the 501c3 nonprofit that kind of helps fund our rOpenSci. Those donations to our rOpenSci are managed by NumFocus. So if you feel so inclined to make a donation or talk to your employer at the end of the year and let them know how much money you made your employer by using our packages, such as those maintained by our rOpenSci, maybe they'll find it in their heart to make a donation to keep this fantastic effort going.
Excellent point, Mike. I just went on the rOpenSci site. Now I have a link directly to the donation page in the show notes. There's a fancy donate button right there that you can kick that off with. And yeah, I know many organizations that are leading this, their own respective R strategies, whether it's life sciences where I'm at or other sectors. One way or another, you're likely touching rOpenSci packages in those transformations. So yeah, those donations would be very much appreciated. And I also appreciate just the wealth of awesome resources that are shared at R Weekly itself. Colin, as usual, has done a fantastic issue here. We're running a bit low on time, so we won't do our additional finds here. But we definitely invite you out there, speaking of keeping community projects going. We don't have NumFocus to fund us on R Weekly, but we do rely heavily on your goodwill and your support to spread the word of R Weekly. One of the best ways to contribute directly is to give us that link to a great new package, a great new blog post showcasing R and data science. Maybe another podcast is talking about R and data science. Who might know a thing or two about that? Who knows? But yeah, there's all those resources are welcome. Where do you do that, of course? You do that at rweekly.org. You got the little octo cat in the upper right corner that will take you directly to our pull request template with the issue draft for next week's issue. Throw your link in there. There's great template language to follow on, and we'll be glad for the coming curator to put that into the upcoming issue. And we love hearing from you as well. And hopefully I didn't botch too much in our audio setup here, but feedback is always welcome nonetheless. You can find me a few different ways. You can find me on Blue Sky, where I am at our podcast at bsky.social. I'm also on Mastodon, where I am at our podcast at podcastindex.social. And I'm on LinkedIn. Just search my name and you'll find me causing some chaos there. And Mike, where can the listeners find you?
On Blue Sky at mike-thomas.bsky.social, or on LinkedIn by searching Ketchbrook Analytics, KETCHBROOK.
Very nice. I keep on the lookout for your fancy posts that you put on there from time to time. And I need to get more into my blogging adventures or podcasting adventures now that I've got this brand new setup. That's about 85% of the way there. And one little dev interlude here. This time around, you've all heard me talk about Nix, right? Well, I'm really deep in Nix now. This new server, the old server, which is now doing some other things in the basement here, and my personal laptop are all coming from one internal Git repo of Nix configurations, fully automated. Yes, I did get help from Claude on this, but it was the way to now make my infrastructure hopefully automated and easy to extend in the near future. So more content hopefully is on the way because of all this. But I'm not sure if it'll be ready by the time I post this, but I will also shout out from our Pharma Hangouts that we just had this past week. We had the esteemed Bruno Rodriguez talking to us about all things Nix and R and his new T language. It was, it's rare that I get to geek out as much as I did on that episode, but boy, I sure did. So the recording will be out on that shortly. Just check randpharma.com for that. I'll put a link to that in the show notes nonetheless. Anyway, let's get you out of here. We are thanking you so much for joining us for this episode of our Weekly Highlights. We will be back with another episode. Hopefully it goes smooth sailing from this point on next week.